All right, we're on to section 10.2, all about concurrency control here. And this is the idea of how do we manage the concurrent transactions in a multi-user database. Now, the main problems we get from multiple users accessing the data at the same time are lost updates, uncommitted data, and inconsistent retrievals. There's an I in there somewhere. Oh goodness. No, it's over on that side. Retrievals. Okay, so when we're dealing with concurrency, we want to make sure that when multiple transactions are running, we maintain those ACID properties of our transaction, right? It's the atomicity of it, the, oh my goodness, the isolation of it, the durability of it, and C, why can I not remember what the C stands for? So like if we're erasing all the stuff we had in here earlier. So when we talk about a lost update, we talked a little bit about if two people want to buy the same widget all at once, right? So we have our product table and we're saying, hey, we're going to take our quantity and we're going to sell 10 of them. And then we're going to take our quantity and we're going to sell 20 of them. And originally the quantity was 30. Okay, so what should normally happen is we should take our 30, we should subtract 10, go down to 20, and then subtract 20 and go down to 0. That's the normal operations, what we'd like to have happen. But what can happen if we don't manage concurrency here is that we can say, okay, well, in this formula of quantity minus 10 and quantity minus 20, they both read quantity as 30. So this one says, okay, this is now 30 minus 10, and this one is 30 minus 20. So this one updates the database and says, okay, there's 20 left. This one updates the database and says there's 10 left. So we've lost that update at this point here because we didn't properly execute these in the right order. So concurrency is a big deal. You can see this will give you some really bad stuff. The problem with uncommitted data is that if we are accessing data before it's been committed, we can get into a bad state. So we were to say the same process here. If we had a quantity of 30 and we said, okay, I want to sell 10 and then I want to sell 20. So in our first update, perfectly fine, we'll say, okay, great. I have 30 minus 10. I'm going to be at 20 here. And then our second one says, okay, now I have 20 minus 20. I'm going to be at 0 here. But then if we say, oops, something else in this transaction failed, I want to roll it back. We roll back that update, and now my quantity is back to 30 here. And now we go and we update and we say, oh, now the quantity is 0 because this one finally applies. So if we're reading uncommitted data and something rolls back, we're also in a bad state here. So we need to be super careful when we're dealing with the idea that an entire transaction has to happen or not. And we're not going to be reading data that hasn't been committed yet because something else could go wrong here. Right, and the third problem, the inconsistent retrievals. Consistent retrievals. I.e., there we go, retrievals. English is so weird. So most often this seems to happen when, excuse me, if we want to do some sort of aggregate function, right, if we want to do an aggregate, if we say, okay, hey, give me the total price, total value of widgets, of products on hand. So we're going to take the price of our item times the quantity, right, for each item, and then we're going to sum all of those together here. Sum the price and the quantity for each of these, right? Price and quantity for each of these, price and quantity for each of these, price and quantity for each of these. So what can happen is I might go get this sum, and then this value might get updated because we just sold some widgets. Now this quantity is, instead of being 30, now it's down to 20. So while that aggregate is running, if the data is updated, right, at the same time here, my aggregate is going to be off here. So, and then if I run my aggregate again, right, if it's inconsistent, if I try and go do another sum, I'm going to get a different value, right, because it depends on whether or not I'm doing the aggregate before or after this transaction happens. So we need to be careful with this, and the process that handles this is known as the scheduler. So the scheduler's job is to look at the serializability of all of our transactions and to make sure that they are scheduled in a way that we don't run into any of those three issues. So it makes sure that we're doing things more than one at a time, right? So if we had to do one thing at a time, 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 and that was the only way we could operate, right? You can imagine that would work for a small set of data, but when you get larger and larger and larger, and we can imagine really big scale things like Amazon. If you have thousands of transactions happening every second, you can't do one at a time, right? We need to do them concurrently because we have multiple people using the database at the same time. So the scheduler's job is to make sure that the transactions are scheduled in such a way that we maintain the serializability. Maintain our serializability. Serializability. That if we were to do them one at a time, we'd get the same results as if we're doing, 1, 2, and 4. If we do them all at once and then we run transaction 3, we get the same results as doing 1 and then 2 and then 3 and then 4. Because if 1, 2, and 4 are all touching different pieces of data, it doesn't matter. It's not going to be a big deal for us to run them at the same time because nothing's going to overlap. So the schedule has to look at that and deal with, okay, what's going to happen here? So if this transaction is a read transaction, it's perfectly fine. There's not going to be a conflict with a different read transaction, right? So read and read will never have a conflict. If there's a read and a write, right? If I'm trying to read data, if this process is trying to write data and I'm trying to read that data, we could have a conflict. Or if I'm trying to write data and they're trying to read the data, right? We could also have a conflict. If we're both trying to write the data, then obviously we're going to have a conflict. So there's a couple different methods we're going to look at for dealing with this concurrency and controlling it, the way that the scheduler is going to manage this for us. So the big one we're going to focus on is locking, because that's the most common one and we're able to manage locks relatively easily. The book will also cover timestamping and optimistic methods. We're not going to bother getting into that. So we're going to talk about locking and then we'll jump into later in the chapter here.